Hello everyone. Today I'm going to start a new series which will be all about quantum mechanics. So, I hope you enjoy it, and let's begin our first video, which will be about the wave function. So, what is the wave function? The wave function is just psi, x and t. So, what does this actually mean, right? So, let's just draw a graph of psi, modulus of psi squared against x. Let's just draw a little curve. Okay, so what does this mean? What does this represent? So, the area under this graph, first of all, x is the displacement in one dimension. So the area under this graph represents the probability density of a particle being existing between A and B at time t. So, how do we write this mathematically? So, we can integrate under the graph between A and B integrating this equation. So that gives you the probability density of a particle being between A and B. And this is one of the most fundamental concepts of quantum mechanics. This is called Born's statistical interpretation. Okay, so there's another thing we need to know before we can move on. If you've done any probability with continuous graphs, you will know that the area under a continuous probability graph is always 1, because the probability always adds up to 1. Okay? So in this case, this is a continuous probability graph, so the area under it should be 1. So if we integrate between negative infinity and positive infinity, we should be able to write this statement right here. But we can't just add in conditions without checking it works with our original equation, which is Schrodinger's equation, which I'll talk about in a later video. So what we do in this case is we just add a constant to make this integral evaluate to 1. Okay, so now I'm going to walk you through an example problem and show you how you can apply this concept. Okay, so here we have the wave function, and our question is normalize this. And as you can see, A is the constant we added earlier to normalize our wave function. So, how do we actually approach this? So first thing you need to remember is that, I'll write it bigger, the integral from negative to positive infinity is 1. Right? It's 1. But in this case, we can just do it between 0 and b, because we know that beyond B it's just 0. So we can do that. Okay, so let's start integrating. So first of all, we have the integral of this, which will be the integral of this between 0 and a, which will be 0 and a, and we can take out modulus of a squared, and you can also take out a squared. So this will be just x squared dx. And then we can add our next value, which is our next function, which is this. So we can take out the modulus of a squared over b minus a squared. And then it's the integral from a to b of the modulus of b minus x squared. Okay, so this equals 1. So next we just need to evaluate our functions. So this bit is just a squared over, this bit is the modulus of a squared over a squared, and then the integral of x squared is just a third x to the 3. And then we sub a and we take away a third x to the 3, but x is 0, so that's just 0. So we just do times third a to the 3 plus modulus squared of a over b minus a squared. And this, we're gonna, next bit we're gonna evaluate. So this is b minus x squared. So the integral of that would just be b minus x to the 3 over 3. So this is evaluated between the limits of b and a. Okay. So, sorry, my bad, this is negative b minus x cubed over 3. So now this is equal to 1, and then we just need to evaluate this bit. So I'm just going to do that over here. So this is going to be, for the first one it's going to be minus b, so that's just 0, so the first one is 0. Then the other one is b minus a cubed over 3, but it's negative. So it's just going to be positive, so it's going to be b minus a cubed over 3. So now let's just put this back here. So let's just do some cancelling out. So a cubed over a squared, that will be just a on the top. So it'll be modulus of a squared over 3 times a plus, we're going to multiply this bit by this, which this is going to cancel out, so it will just give us modulus of a squared over 3 times b minus a, times b minus a, and this should equal 1, right? So I'm just going to get rid of this bit here so we have more space. Okay, so we can just multiply through by 3, which will give us modulus a squared a plus modulus a squared b minus a equals 3. So now we can just factorize this statement here, and that'll give us modulus of a squared times a plus b minus a, so that just, your a cancels out, so just a modulus a squared b equals 3, so you get a equals the square root of 3 over b. So there we go, we found our constant a. So this is how you actually normalize a function, in this case this function, to have the area under the graph equal 1. Thank you very much for watching.